Now we will see the next method. The name of the method is Gauss Elimination. So suppose I have three equation like this, three linear equation, or you can have more than three, but for this explanation, for simplify the explanation, I will use only three equation. So in Gauss elimination, the focus of this method is change this matrix into triangular matrix. What is triangular matrix? Triangular matrix is a matrix which has 0 for its triangular, one side of its triangular, and then another side of triangular will be non-zero, and the diagonal will not be 0. So diagonal with not 0, and then the this we call upper triangular element will be non-zero, but here the lower element, the lower triangular element is 0. Well, actually you can change this lower triangular is not 0 and the upper triangular is 0, then it's also we call as triangular matrix. So here I choose the upper triangular, but you can also use the lower triangular, and the how this method works will be the same if you choose the lower triangular or upper triangular. So first, what we have to do, after we have the triangular matrix, then we can find the x3. If you use lower triangular, then you can find the x1 first, but here I give you the example using upper triangular so that we can find the x3 first. This x3 is the C double accent 3 divided by 8 double accent 3, the coefficient of this one, but it's already changed into a double accent. After you having the x3, then you can find the x2. You cannot directly find the x1, you have to find x2 first, then x2 you can find by calculating this C2 minus a23 multiplied by the x3. This is the x3 that we calculate before, and then divide by a accent 22. After having the x3, then you can calculate x1, and the x1 is like this, and you have here x2 and x3 so that you can find what is x1. So this is how the Gauss elimination works. Now let us see an example. Suppose I have this linear equation, and then I write the matrix, then this is the matrix. If I use Gauss elimination, then I have to change this matrix into triangular matrix. How to do that? I have to change this 0.1, 0.3 and minus 0.2 become 0. This should become 0. How to do that? We have to change this first column 0.1 and 0.3 into 0. How to do that? We do this operation. The first operation is I change the first coefficient, first row coefficient, first row and first column become 1. So I divide by 3, so it's become 1, and then I multiply with the coefficient of the second row 0.1, and I just divide it by this, I'm sorry, not divide, but subtract with this coefficient. So minus 0.1 plus 0.1, so it's become 0. Then write the answer into are true. R2 means this, so I have to write this operation into the second operation. So the first operation, the first row will be keep like this, so it will not change, but only the second row will change because of this operation. And to change the third operation, I do almost the same thing. I divide this coefficient with 3, so it's become 1, and then I multiply with this coefficient and I just subtract it and put the result in this row. Then after doing this, I will have this matrix. So this is still the same, the first row, and then the second row, the first coefficient becomes 0 and 0. The third row also becomes 0. After having this matrix, the only thing that we have to change, which is the coefficient of the second column of the third row, which is minus 0.19. we have to change this into 0. If this becomes 0, then I will have a triangular matrix. So let's just change this. How to change? I do this operation. So I will use the second row, not the first row, because this already becomes 0. So whatever it is, it will not give influence into this coefficient. So this will be always 0. So I will use this second row. If I use the first row, then this coefficient will change because of this one. So I will do this one, minus 0.19 divide by 7.0033 and multiply the second row and subtract with the third row and put the result into the third row. Then I will have this become triangular matrix because this already becomes 0. So now I have triangular matrix. So my Gauss elimination already finished. Then I just need to substitute the result. If I substitute the result, start from the x3. x3 is x3 is 70 comma something, divide by this, then the result will be 7.003. and then after you have x3, you calculate x2, then you will have this. After you having x2 and x3, you can calculate x1. This is 3. And if you want to check whether this answer correct or not, you just plug in this x1, x2 and x3 to the linear equation that you have. If you plug it, then you will have, from the first equation, you will have this one. Yeah, it's near to 7.85. and then the second equation will have the same or equal result, and then the third result is almost the same. So this is correct, your answer is correct. And this is all about Gauss elimination, and we will discuss this further about the properties or the trap inside of this method.